Right, now the point of this is to show you what I typically get sent by final year project students who go, can you help me with my data please? So this is with the names removed to protect the innocent, an example of a final year project file project. Now this is their data in Excel, and this is the aim of this is to convince you that Excel is a bad idea in almost every possible circumstance. So here is their Excel file. To be honest, this makes me want to cry every time I see it, and that's what it looks like. So first thing you need to do, and the first thing you need to do whenever you deal with data is think, where's it come from? I mean, what were you doing to get the data? So ignore the spelling errors because that doesn't matter. That's time. That's not an issue whatsoever. So what you've got is a particular method for doing clotting of blood, which is called a PT assay. You've done the assays at different temperatures. 8 degrees, that's pretty cold. 20 degrees, 30 degrees, 37 degrees, 40 degrees, 50 degrees, and 60 degrees. What you're looking for is the blood to clot, and you're looking for the time it takes to clot, and you're measuring it in hopefully seconds, because if this is minutes, you're in a mess. Minutes are not good units for time because of this 60 seconds in a minute kind of thing, and they don't fit into decimals. Don't do anything that's not decimal, ever. Just don't. Horrible for data. So 8 degrees, nothing happened. 60 degrees, nothing happened. 8 degrees is probably too cold for the assay. 60 degrees, the coagulation properties have gone to hell. It's not going to work. You've boiled your blood. Here are the times 20, 30. You've done repeats at each of the different times. So what's wrong with this way of doing data? Just like everything, you've put a table of data in the middle of the sheet. You've not used the natural columns and rows to actually mean anything. You've just popped it in the middle of there. Yeah, there's no labeling. You've got no real idea. I know these are seconds because I know the experiment. But any poor person who gets this in the future has absolutely no idea what's happening. Now, this is an experiment which has really two variables. It has temperature of the heating bath, and it has time for coagulation. So this data should be in two columns: temperature, time for coagulation. That's it. Everything else is totally and utterly meaningless. So putting it in the middle of a spreadsheet like this, arranged in this particular order, so you've got rows that are the replicants or whatever, it's a mess. I did go and reformat it, so at least this uses the natural space of the spreadsheet. So I'm just going to copy the data from there. So I'm going to Control-C it into here. So there's the data in at least a reasonable format where I've got rows and columns to have some kind of meaning, and I'm using the columns and rows of the spreadsheet sensibly. So I'm starting at 1 and my data starting at 2. So it goes from B2 to B4 and so on. I can do that. So here I can't calculate an average of nothing happening. Nothing happening. Oops. So we've got NA for these. Now, below that they calculated the mean. So here you see if I click on the formula for the mean, it goes equals average E5 to E7. Fine. But it's a lot more. It's a lot easier to do if it's more systematic, so you don't have to find where your data is located on your sheet. So equals average. Oh, you've got average if. That's interesting. That's reasonably interesting because you could do the equals average even for that column that has no plot, and say equal average if you find a number there. So then if it didn't see a number, then it'd ignore that piece of data. Equals average, and I want it from, what am I in? I'm on C to C5. Oops, I haven't C2 to C4. That would be better. See what I mean? At 20.303, everything's good. Now to calculate that mean, I had to know that you have to type in equals average. I had to know the way Excel works in typing a formula in there. Next, I want to do the standard deviation. So it's equals STDEV. Now, if you can see this, yeah, you should be able to see it reasonably clearly. There's, well, let's go to SDD. So standard deviation, there's quite a lot of standard deviation things that I can do. Now, there's these top 4 ones, STDEV P, S, VA, VPA. A and PA, sorry. Then there's 2 below it which have got little yellow warnings on it, STDEV and STDEV-P. So this is telling you that this STDEV here is the old standard deviation formula that Excel used to use before 2015, when it updated and redefined how the standard deviation is calculated. So up until that point, you had STDEV and STDEV-P. These were replaced by the functions STDEV-P and STDEV-S. So STDEV-S is the same as that original STDEV. Now, to know which one you need to use and which one you need to calculate, you need to understand that STDEV-P stands for the population standard deviation and STDEV-S stands for the sample standard deviation. And that when you collect any data set, it's a sample, not the population. Therefore, you always want to use STDEV-S. You see all of that background thinking that you need in order to use Excel. So it's between C2 and C4. Here's what I think it's done. So it's 0.18, whatever it is. But I have to have that background knowledge if I'm going to use Excel. Now I could just copy that function. So I can Control-C it all the way across in that row, and it will repeat it. And I can copy that function by dragging that bottom corner across to the others. So that's all done. I've got my complete set of standard deviations. And I can check that it's doing this by checking clicking on it and checking the formula. Equals stdev.s, whatever. But I still, in Excel, I need to know how statistics work. The other thing that they've calculated here is the CV. Now, I got myself a bit flummoxed when I was doing this on Tuesday. I was going, So I know why you want to do the CV, and I know what the CV is. So I was a bit flummoxed when I looked at what they'd calculated here for the CV. They said it's E9 over E8 times 100 as a percentage. And I go, So anyway, this morning before I started, I checked about why we're supposed to do with CV. Now, this is a reasonable amount of data for a final year project. This is one experiment. They actually did this 4 times using 4 different sets of conditions. So this is a quarter of their final year data. Projects don't have to have an awful lot of data. My projects, they do, but that's mainly because I'm a parasite. Other people do the data collection. I take their data and reanalyze it and do it properly and get the right results, as opposed to them doing it wrong. So mine have a tendency to have about 48,000 rows of data on. So they're a bit bigger than this, but it's because someone else has collected it and I didn't. Right, now, coefficient of variation is what we call a dimensionless dimensionless quantity. It's a ratio. Now, the reason for this is the mean has a unit, which are seconds. The standard deviation has units which are seconds. The variance has units which are seconds squared. Now, if I want to compare the variability in the weight of mice to the variability in the weight of elephants, that's a bit of a silly question, because obviously an elephant is going to vary by an awful lot more than a mouse. But relatively, do they? So if I take the units out, I can see the ratio of the standard deviation in terms of number of means. Now, this is the coefficient of variation and tells you how precise your measurements are. So it should be equals C6 divided by C5. It is 0.000. You never multiply it by 100. You don't turn it into a percentage. So this is not a CV. That is the percentage of variation that you get compared to the mean. All of these things are bad things to report, but we'll come to that later when I explain how statistics should be done. Like, this has got so many errors in it that I don't want to think about it. That would be the coefficient of variation. It's dimensionless, as I said. It doesn't have any units because I've divided something that had seconds by something that had seconds, so the seconds cancel out with each other. Mathematicians like it because it gives you an indication of precision of that particular measurement, but anybody who's not a mathematician is probably irrelevant. I'm going to save this one as why can't I save in downloads? Better Excel file. I'll call it Better Excel file 1. So that's the final file that I want to do. Now, let's go and get the same data in SPSS. Now, remember I told you there's actually only two variables there. There's temperature of your water bath, and there's how long it took you to coagulate, the time. So actually, let's put that vector as time and label coagulation time. Now, the temperature is in theory a scale measurement. It's continuous, but you've actually picked specific set of temperatures. You don't allow temperatures to vary freely. You're not allowing the experiment to go on whatever temperature you find in the lab that day and measuring the temperature. You're setting specified temperatures in specified points. So in this case, while it is a scale, it's really more like an ordinal variable. Okay. So I'm going to save that. So updated. So I've got temperature and I've got time. Now you see that your repeats, you've got 3 for each of those, represented by you've got the temperature repeated 3 times all the way down. Yes. Now 0 means that they had no coagulation. So the other thing I need to do here is define that it's got discrete missing value, and 0 means nothing happened. So now SPSS will ignore those when it comes to doing any calculations. I might save that file again. So in that previous case, I wanted to find out the mean and the standard deviation. Let's forget the coefficient of variation because I don't think it's that important. So how can I do it in SPSS? I go to Analyze. I go to Descriptive Statistics because the mean and the standard deviation are examples of descriptive statistics. I go to Explore. I want to do coagulation time. That's the thing that I want to find the averages of. And I want to split it up by temperature. So I want to find an average of each of the different temperatures. So I put the temperature in and I press OK. It reports what it's done. So it says there's 3 values for each of the different temperatures. It tells me, it should have told me, well, it's removed all of the cases for 8. So they didn't calculate anything. It should also have removed all the cases for temperature 60. Yes, they don't occur in the data table. and it says mean 20.3033. And I've got my file. What do I get? 20.3033. Standard deviation in the table is 0.18502. Standard deviation is 0.18502. So SPSS has given me exactly the same thing as I did before, but I didn't need to know equals average. I didn't need to type in any of those formulae. I didn't need to know where the cells were. I didn't need to know which one of the standard deviations I needed to do. It automatically tells me I need to do sample because I should never be doing the population one. So it's done everything in one go and tabulated it, along with everything else that I probably didn't want to know. So confidence intervals, variances, maximums, minimums, range, skewness, kurtosis, lots and lots of extra details I don't really want, but it did it just menu driven. So the level, I still need to understand how statistics work, that you need a mean and standard deviation, but I don't need to know it at quite the level I need to use when I'm using Excel. I don't need to know the difference between population and sample standard deviation, for example. It automatically knows that I need to do this one and does it correctly. So it's done for each of the different temperatures, and I didn't need to do anything. It also gave me a stem and leaf plot, which for 3 data points is a bit stupid, but nicely it's given me this other plot, which is called a box plot, and my favorite plot in the entire world. You've got coagulation time and temperature. It's labeled things. If I did a more intelligent label, if I did coagulation time and put the units in there, it would have labeled it even better. And if I put temp and it's not in Kelvin, it's going to be in degrees Celsius, then that would be even more amazing. And you can see that as you change the temperature, there's a decline in the coagulation time. It's sort of linear. It's a bit S-shaped at the end. So it has a point of inflection, I suppose. It's flattish S and then flattening out at the bottom. So you can see instantly, just by that analysis, that you've got a dependency of coagulation time based on temperature. You can see the relationship, and you've got all of the analysis you wanted to do in one place. You could stick there. That would be enough analysis for your project. Yes, what did you want to ask? You didn't want to ask. An accidental hand raised. It's okay, you can ask something if you want to. Okay. That's why you should be using SPSS, because it forces you into putting the data in the right format. So thinking about what your data means. So as I said, when you're looking at it to start with, and this data, you have temperature and time for coagulation, but it's not immediately clear what your variables are that you're studying. Once you've got it into SPSS like this, it's very clear what you're studying and what your dependent and independent variables are going to be, and what kind of plots you can do, and if you want to do scatter or so on. SPSS makes it clear what analysis you need to do, and it makes it very easy to carry out that analysis. And that's why I want you to use SPSS and not Excel.